It is me, Mr. Campbell. We are back here with our first ever Earth Space Science video lesson, and I couldn't be more excited. I've been trying new things, trying to kind of improve these videos and do different things. For example, I did try to implement some music stuff and other things like that, but it didn't quite work out so well. It kind of had some technical difficulties. So I'll go with kind of do this the same way I did it the first time. But before I move on and start the lesson, again, I'm always going to try to get within 15 to 20 minutes for every lesson. And like I said, I may kind of speak a little fast here to meet that time limit. So always make sure you pause and do the necessary thing with that. That way you're up to speed on everything we talk about within each video lesson. But as I said, before I get into all that, I want to first off and start us off by telling you guys, and let me kind of fix this really quick so that it's higher quality. I want to start us off by saying thank you. Thank you all for watching my first video. Thank you for the great response. A lot of people watched it. You guys are with it. You guys are ready to go. We've just got one more quarter and then it's summer break. So again, off to a good start. Staying with me on track on the daily with this. You guys will be set to go and on the right track to success and doing a phenomenal job this last quarter. But with that being mentioned, what do you need for these video lessons? As you would in our class, just need a writing utensil, pen or pencil, and have something to write on. Notebook. A lot of you guys, your notebooks are still at school, so have some sheets of paper or notebook at home. No problem with me. Just make sure you have a frame of reference for everything we go over in our video lessons. Also, make sure again you're keeping those sheets, keeping those notes for reference for, like we said, those unit quizzes. Not only that, we are going to be having notebook checks. Yes, you're going to be submitting online on a post link random pages that I'll request of your notebook that we take throughout these video lessons every other week. So just like we have weekly quizzes, you're going to have every other week you're going to have a notebook check. Let's move on now to our Go Blue. We have our first three questions. Again, take a moment, pause the video, and write these down. Number one, who proposed the heliocentric model? Who proposed the idea that the sun was at the center of our solar system? And then number two, how do we prove that Earth is not at the center of our solar system? If I look up at the sky, I see things moving around us, right? So how do I know that Earth's not the center? What proof can you show me? What evidence do you have to disprove that idea? And then three, what is retrograde, right? An important topic we need to know. What does it mean? You may remember it from last time. Again, copy that to page 7 or page 8B if you do not have room. Before I get to that, let's also go over some announcements. First, third quarter grades have been completed and are submitted. Those will be ready for you guys in a few weeks. Notebook checks, again, every other Friday. Super important, though, for the time being. We've got two things on Friday. We've got our first unit quiz, 10 to 15 questions. Prep for that. Recording for these video lessons is huge. Do well on those. And lastly, you guys are going to be having article questions you need to answer with the article reading about the the sun's impact on everyday life for us humans. Let me go ahead and take us now to Edsby to show you guys that. Okay, so if I look here, you guys can see here's my post. It says assignment, solar articles. Directions are here. Questions are below. I could read those word for word, but I just got to keep things short and to the point, so I won't. All you got to do, again, is write the numbers of the questions, write your answers after reading and analyzing those articles. If I click the solar article link, you guys will see the articles attached with this. If I click on that, again, article number 1 is just 2 pages front and back. Articles 2 and 3 are just 1 page, one-sided. So again, 2 questions for 1 and 2, 1 question for article number 3. Okay. So going back there, again, you're going to submit these online through Edsby. There should be a submit button here. You'll attach your document. Again, each question is 5 points. Should be a well-rounded, easy 25 points, just simple article analysis. Always good to get a little reading and little analysis there from that point of view, right? So again, just some topics to know about and be aware of. Again, solar storms, solar wind, auroras, satellites, right? So all important key ideas to know about. Again, do not send me typed submissions, and do not make sure your name and it is your handwritten assignment that you take pictures of that you submit on the link. Let's go back and get back to our presentation, back to our Go Blue. And as you guys can see here, our questions number 1, who proposed the heliocentric model? You should have already answered. That person was Nicholas Copernicus. Yes, first person to come up with the idea of a sun being at the center of our solar system. Of course, as you may assume, nobody believed him. Nobody thought he was right. And as often with great ideas, it takes later time and much greater support for it to become indeed fact and indeed true. And that, number 2, would be just, how do we know that the Earth is not at the center? Because people back then, they looked up, they saw things going around the Earth, right? How in the world is the sun at the center? We now have devices such as telescopes. We have satellites, and we have retrograde motion, segueing us to our third question of what you ask? Planets and moons having retrograde motion. What in the world is retrograde motion? For number 3, it is, guys, remember, write these down, guys, everything in yellow, make sure to get down. It is the apparent backwards motion of planets from our perspective. So all these astronomers at the time, before the technology was really made, would look up with their old school telescopes, and they see some planets would be moving like in a loop, in a backwards loop, okay? And what causes this? Do all planets move at the same speed? No, okay? Planets all move at different speeds because they're different distances from the sun. So Mercury, closest to the sun, moves around the sun. A year on Mercury is 88 days. A year on the dwarf planet, famously known as Pluto, okay, it takes 250 years roughly to get around the sun. Long time. Big difference there, right? And if you look at it from our perspective, those planets are going to be making these loops, which kind of tells us that we're not the center if they're not looping around us. They're looping around something else. I'm going to go ahead and show you guys a quick video that kind of illustrates this idea. Some of you guys, I've shown this to you already. Most of you, I don't think I have yet. So let's take a look at that link here. Pretty cool stuff. I'm going to be totally honest with you guys. This is my 5th attempt at making this video. I've tried all sorts of things that didn't work. So hopefully I'm doing a good job of minimizing the distracting, yada, yada. I'm not babbling too much, right? Okay, so retrograde motion, let's kind of visualize this.
It's an illusion that unfolds over a matter of weeks or months. In this image, Mars was photographed every 5 to 7 days between October 2011 and July 2012. Once all the photos were combined by aligning the stars in the background, it appears as though Mars looped back on itself before
So there's that loop. Again, what's causing that?
continuing on its orbit. A retrograde illusion like this happens when we lap an outer planet like we do with Mars every 2 years, or when an inner planet laps Earth like Mercury does every.
So just like runners on a track, every track lane is a different distance, okay? That's why they have different starting points in a lot of track meet events, right? So Mercury's really fast. It's like closest to the center. It's got a lot of gravity being used on it from the sun. So when we look at Mercury from our perspective, it's going to be making a lot of loops because it's going around the sun. It's turning a lot earlier than Earth is. Its turn is a lot faster. Mars, on the other hand, is farther. So we turn earlier than Mars does, which makes it look like it's doing a loop too. That is retrograde. We've talked about it. You visualize it. I think we're all set. Awesome, awesome. Okay, let's go ahead and, as we usually do in class, let's move on to our first table of contents. Is the same as last time. If you need to get caught up, go ahead and pause the video. Get that caught up as well if you've got your notebook with you. Let's do our first practice question, though. Again, if you had your cards, we would have those up and ready to go. Am I right? Good refresher from the break, though. It's been 2 weeks. It's been a long time. What 2 elements primarily make up most of the sun? A, hydrogen, iron. B, helium and nitrogen. C, hydrogen and nitrogen. Or D, hydrogen and helium. Take a moment, pause the video, give it your best thought. The answer is going to be D, hydrogen and helium. Most of which is hydrogen. Smaller portion is helium. Think of the sun kind of like a balloon. that amount of helium has a big impact on it. We'll get into that another day. All right, let's go ahead and move on. What I'd like you guys to do after that question is go ahead and, again, what you see in yellow, go ahead and write that down. I believe this was like a fill in the blank sheet in our notebooks, and a lot of you don't have those. So you have the fill in the blanks. Some of it's edited, so it may not fit the fill in the blanks perfectly anymore. My apologies for that. Again, I recommend just kind of writing down what on the next free space. That way, it kind of makes it easier for everybody. Maybe easier for you if you had the fill in the blanks. So let me go ahead and find that and go to share. Oh, what I was looking for. Is this it? Here we go. All right, we talked about heliocentric, but who were the other important figures we need to know? Okay, besides Copernicus, we've got Tycho Brahe. Okay, and all we need to know is that he really was really innovative in building equipment that kind of improved the telescope, improved a lot of our astronomy equipment. So he built the foundation for who we need to know about later, which is Galileo. Then super important is Kepler. Kepler specifically studied the movement of the planets. Okay, he looked at how planets orbited the sun, the speed and the shape. Super important to know. Let me kind of move my screen up here. Super important to know is this word elliptical. Planets move in an ellipse. They don't orbit the sun in a perfect circle. And in fact, the sun is not even at the center of that orbit. Okay, let me go ahead and kind of show you guys how this orbit's going to look. Okay, they're going to orbit in what we all remember and know. And I know a lot of you guys may have already seen some of this stuff. Either way, if it's new, get caught up. If it's old, it's a good recap. Have that down as reference because you're going to get quizzed on it anyway Friday, right? If you don't have your notebook with you on hand, it's at school still. Okay, so it kind of orbits in like this oval egg shape, right? And as you can see, the planet speeds up near the sun. So we call that an elliptical, an ellipse, right? That's kind of the example that we see there. Okay, moving back here. Again, I'm going to go fast for you guys. There's an ellipse, but the sun's not at the center. It's wrong. It's incorrect there. Okay, I got some additional videos to look at. You know, nothing urgent with any questions though. That can show you that orbit, right? We have Galileo. Okay, so Galileo, he's a telescope guy. Did not invent the telescope. Nobody here invented the telescope, but he made a lot of incredible discoveries that were important for supporting the heliocentric model. Discovering how other planets move, the moons of other planets, etc. Again, telescope guy. Just keep note, Galileo. Tycho Brahe built the foundation for him. Kind of was like really innovative in those earlier improvements, but Galileo made those big discoveries with the telescope. Okay, we'll get to our last question today, another day. I gotta be quick with this, guys. All I want you to do is for this video, I want you to watch this video. We're gonna go over law versus theory one more time. We went over it back in September and August, but we are tested again on it in the spring. So just quickly make a T-chart on page 7 or 8B, and just one side law, one side theory. You just probably remember this from last time, but just to kind of refresh your memories a little bit. We're only going to talk about law, and then what you guys are going to do when you make the T-chart. Again, you're going to watch this video here. Okay, little TED animation video with our circle and square. Things to think about as you watch this on your own. Law versus theory. Is one better than the other? Can one be disproven? Can they change? Can one become the other?
Better? Scientific law.
Right?
Well, that's just a law. And is one better?
Yeah, I mean,
what?
You get the idea. It's a good video, good animation. You've seen it before. Just to kind of refresh our memory. It's been a while. We're trying to get the circuits firing again, right? Okay. So let's go ahead and go back to this. Hopefully my screen didn't mess up anything. I think I went to desktop on accident. Anyways, so here we go. Fact versus hypothesis. What are they? How are they different? Fact is just truth that we observe in everyday life, observations. Hypothesis, if you guys remember the scientific method, that is the beginning of the method. We just make up a proposition. We make a proposal, and we see if it's indeed true through experimentation. Again, why is the sky blue? It's blue because of, et cetera, et cetera. Why does the apple fall from the tree? It falls because of, et cetera, et cetera. So hypothesis, not law, not theory, just kind of ways, steps that we take to get there. Okay, before we finish up, a few quick things on theories. Again, write these down, pause the video. I'm kind of seeing what we caught up on and what's new, so it's a little I'm kind of cramming things in a little bit. But theory, it's not worse than a law. It's not compared to a law. They're just totally different things. It's like oranges to apples. Okay, a theory is a well-supported explanation. Okay, it's got a lot of evidence. It's been tested. It's confirmed, but it just doesn't involve a math equation. It's just an explanation. It's a topic in science that it can only be explained. It can only be described. It can't be equated like force or gravity. Those are laws can be, which means what makes something a theory? Well, it can change. It can be modified. It can improve. Theories change. Laws do not. Again, as I said earlier, it has to be tested, but it also explains why or how. A law is what, a theory is why or how. A theory is the long text message. A law is the one word or the one emoji text message, right? One's very concrete and short. The other one is very long and descriptive. Okay, so let's go ahead, check out, last thing I want you to write is the examples of theories, guys. So evolution, Big Bang, heliocentric, geocentric, we've gone over 3 of those 4. The Big Bang we're going to go over fairly soon. Again, scientists proposing how the universe may have begun. And just so you guys know, that completes and finishes our new information for the day. I kind of crammed some stuff a little bit, new stuff. And I only did that because I'm just kind of, some classes are a little ahead, some classes are not. So I figured I'd kind of get us all on the same page a little bit as we go through these video lessons. And let's take a look at our last question of the day before I let you guys work on your article questions. What process helps power the sun? Is it A, nuclear fission, B, nuclear fusion, C, photosynthesis, or D, solar magnetism? And think about it, pause. The correct answer is going to be B, nuclear fusion. Hydrogen and helium fusing together to power the sun for billions of years. Go ahead, guys, and work on your article analysis questions. Prep your notebooks and your notes for that quiz on Friday. And you guys, again, hope you have an awesome first day of your virtual learning. This is Mr. Campbell signing out. Message me with any questions. Hope you guys have an awesome day. Take care. Have a good one. I'll see you guys on Tuesday.